So you see one thing, মা এই মিষ্টিটা ওকে দিতে গেলে একটু গরম করে দিও, এটা পুরো ইটের মতো শক্ত হয়ে যাবে। এটা এটো হয়ে গেছে, মুখে দিয়ে So, I was about to ask you something. Q. How many infinities does R? Anyone? How many infinities does R have?
মানে
মানে আর এর কতগুলো ইনফিনিটি আছে, এটা একটাই মানে।
প্লাস
আরে
ইনফিনিটি
একটাই,
মাইনাস
সরি,
ও আচ্ছা,
দুটো না, প্লাস ইনফিনিটি আর মাইনাস ইনফিনিটি।
okay. So see, the thing is, it is not true. Okay, R only has one infinity. Okay, let me tell you why. So R is, from R you can give a bijection. I think I have, you know the bijection, I mean from
তুমি কি কার্ডিনাল সেটটার কি হবে ভ্যালু সেটা জিজ্ঞাসা করছো নাকি?
no. Do you know the map?
tan inverse x,
tan x, tan inverse x. This is a homeomorphism,
bijection,
right? Homeomorphism. It's even more. In fact, I would say it's a diffeomorphism. Diffeomorphism. By that I mean F and F inverse. If both of them are continuous, we say it's a homeomorphism. If F and F inverse, both of them are differentiable, we say it's a diffeomorphism. So it's a diffeomorphism because I mean you can have tan inverse from R to minus pi by 2 to pi by 2. This is again a homeomorphism, right? I mean, so now you see this thing. So let me write this, minus pi by 2 to pi by 2. Okay, from there I'm using a map to what? R2. Okay, the map is x will go to Can you tell me what is the image of psi? What is the image of psi? So first we define S1 to be the unit circle, okay? Right? I mean S1 is basically x comma y belongs to, maybe I should have written it like in terms of t going to cos 2t sine 2t. X square plus y square equals to 1, right? The unit circle. So can you tell me what is the image of psi? I think it is, I think image of psi is basically S1 minus minus what? S1 minus বল না কেউ একটা cos 2 pi কত হচ্ছে ওটা? Cos pi. What is cos pi? Cos pi is minus 1, no?
Minus 1.
Okay. So basically this is the point. Am I correct? Right. This is the point, no?
দাদা বলছি যদি আমি ক্যালকুলেশন করে বের করতে চাই কি করে করবো?
মানে
মানে যদি আমি প্রুফ করতে চাই যে এটার ইমেজ এটা আসবে কি করে প্রুফ করবো?
you want to prove it.
হ্যাঁ
So pick up a point from here and get a pre-image here. Only minus 1 comma 0 won't have a pre-image.
না না ওটা তো আগে থেকে আমরা জেনে আসি যে ওটার ইমেজ ওটা হবে, কিন্তু আমি ধরো জানি না ইমেজটা, বাট আমি বের করতেছি।
Okay, so you realize what is this map. This is the whole circle, okay? That's the catch. Okay, this is the whole circle.
হ্যাঁ
So you are removing these two ends, hence their image as well. So see, why did I actually wanted to tell you all this? There is a reason. So this is a circle minus a point, right? This circle looks like correct?
হ্যাঁ
Correct? And you can rotate this circle. I mean, you can have this circle like this. You can have this circle like this. I mean, I have just rotated this circle. So concentrate more on this diagram. I mean, there is a reason. There is a reason. Okay. See, I can just write a map here. I'm just not willing to do that. If you want me to do that, I will do it. Okay. So you observe one thing. First you write here R2. Then you write here minus pi by 2 to pi by 2. Then you write here S1 minus singleton 1 comma 0 minus 1 comma 0 inside what? Inside R2. And suppose you even rotate it. Okay, rotation by what? You will have to rotate it 90 degree, right? By what?
Clockwise.
So what will be the matrix? Just multiplication by this matrix. I mean, I think is pi by 2 clockwise. So I think it will be cos pi by 2 sin pi by 2
minus sin pi by 2 cos pi by 2.
Now you may say that why, what's wrong with figure 1? Why are we going to figure 2? Right? There is a reason. You will, I mean, you will see immediately. Is just for some visual satisfaction, I would say. So the matrix multiplication is by cos pi by 2 sin pi by 2 minus sin pi by 2 cos pi by 2. Or even you can think it as like multiplication by e to the power minus I pi by 2, right? That is minus I. You can, I mean, you can think R2 equals to C, okay? You remember the last day we actually established a correspondence between these things, like e to the power I theta and cos theta sin theta minus sin theta cos theta, those metrics. So you observe that at each point, I mean, here it was tan inverse, there it was psi, and let's write it at A. Each of these matrices are homeomorphisms. Okay? Each of these matrices are homeomorphisms. I mean, maps are homeomorphisms. So you take theta, not relative theta, maybe some other map, maybe phi. You define phi to be A composition psi, composition tan inverse is a homeomorphism between, at least correct me, between R and S1 minus, right, this thing. So you understand. Now you think one thing. What is the image of infinity here? What is the image of infinity here?
1, 0.
Exactly. Very good. So if we extend phi to R union infinity, then phi becomes a homeomorphism between R union infinity, that is the extended real line, and S1. Okay, the map is clear. The map is clear now. Like phi x is basically A compose psi compose tan inverse of x for x belongs to reals, and 1, 0 if x equals to. That's it. Now you realize that there is only one infinity because phi is a bijection. Phi becomes a homeomorphism, so phi is a bijection. Okay, so R has only one infinity, and S1 is called the 1 point compactification of R. Abhishek, are you aware of this?
হ্যাঁ, পুরো ব্যাপারটা সম্পর্কে আমি অ্যাওয়ার, কিন্তু এই যে তুমি যে কি লিখলে 1 পয়েন্ট কম্প্যাক্টিফিকেশন, এই টার্মিনোলজিটার মানেটা কি?
You are adding one point to R to make it compact.
ও আচ্ছা আচ্ছা, ইনটিউটিভ টোপোলজিতে পড়েছিলাম এই মানে আরো কমপ্লেক্স স্ট্রাকচার নিয়ে এগুলো।
তো স্টোন চেক কম্প্যাক্টিফিকেশন।
So basically what you are doing is, so let me tell you what you are doing is that, so you have this infinite real line, okay. So first, by tan inverse, you are making it an open segment, okay. Then you are making it a circle like this, okay. So you are sort of bending the real line, and you are what should I say, putting the minus infinity and infinity together, okay. Now my next question is, how many infinities does R2 or C have?
ওই
Don't,
এবার তো
okay, there is a thing, I mean, one point compactification, all these things will be done in details in the topology course, okay. So can't go to much details here.
না আমি বলছি যে R2 কে তো আমি মানে হ্যাঁ মানে আমি বলতে চাইছি যে স্টেরিওগ্রাফি প্রজেকশনের মাধ্যমে তো আমি টু স্ফিয়ারে আমি আবার
Very
হোমিওমরফিক
good,
ম্যাপ দেখাতে
very
পারবো।
good, very good. So he is saying that we can extend this idea. How? So he is saying, instead of S1, replace S1 by S2 this time, okay, and replace S1 minus 1 comma 0 by S2 minus 1 comma 0 comma 0, okay. We call it the north pole of S2. So you consider it here, okay. This is your S2, the point here is absent, okay. I think I wrote it wrong, sorry. Okay. So S2 is just sitting on the xy plane, okay. This is the x-axis, this is, I mean, x-axis, y-axis, and this is the z-axis. So this is just sitting on this, okay.
আর একটা অ্যাপ্রোচে হয় তো তুমি ধরো ওই মাঝখান দিয়ে প্লেনটাকে নিয়ে চলে গেলে মানে ইকুয়েটার দিয়ে, তাহলে ওই নিচের হেমিস্ফিয়ারটাকে তুমি ইকুয়েটারে ম্যাপ করালে আর বাকিটাকে তুমি আউটার ইকুয়েটারে ম্যাপ করালে।
I mean, he is saying, why can't I take this plane to bisect the sphere? Actually, this map is easier to write down. Once you try to write it down, you will realize. So what is the function? The function is very clear, okay. So you have to define, say phi from S2 minus n to R2, and you want to define psi from R2 to S2 minus n, okay. So you pick up a point, okay. You pick up a point in S2, okay. So where will it go? You join this point with a straight line from the north pole, okay. You extend it where it cuts the R2 plane, okay. That is the image of A under phi, okay. So this is phi A, clear? And similarly, if you pick up a point, say P in R2, P in R2 and A in R2, so what you do? You join P with the north pole, okay. And exactly where P cuts the sphere, that is the image of P under the map psi. So the map is clear. I mean, we will be able to write it down. It's not a rocket science, okay? You can just take an arbitrary point here. You can just do like x comma y comma 0 here, and there is a, I mean, these, you go and check the stereographic projection, you will get the map there. But I am telling you, is the idea clear? That what am I doing? So first you have a sphere, okay, sitting on a big plane, okay. So this is the North Pole. So I am telling you, if this is your point, where should you map this? You map this to this point, okay. That is the straight line joining North Pole and the point where it cuts the R2, and it is very same for the opposite. Like suppose here is a point P, you join it with N, and you see where it cuts the, and remember it will cut the sphere in only one point. You denote it by psi A, okay. Now you see this is an identity map. I mean the composition is identity, because you come back, if you go from A to phi A, then what is the image of phi A under N and under psi? This is A, right? So this is the stereographic projection which Abhishek was talking about. Stereographic projection. Okay. So again you see this. So psi, you can define psi from R2 union infinity to S2, okay, by defining psi from R2, I mean, what should I write? Psi P is, I mean, here, like as usual, as above, if P belongs to R2, and psi P is N if P is infinity, okay. So this is again a homeomorphism, and by the very same logic, R2 has only one infinity, C has only one infinity, okay. And in this case, you will be able to show every Rn has only one infinity. Remark, Rn union infinity is homeomorphic to Sn. Thus, Rn has only one okay. Now one you might ask, I mean, what is the topology in Rn union infinity, right? I mean, that's the natural question, na? I mean, when you are defining Rn union infinity, I mean, we know the topology in Rn, right? So what is the topology in Rn union infinity? Has the following topology. O subset of Rn union infinity is open if case 1, O is a subset of R2, is an open subset of R2. This is one case. I mean, if O is an open subset of R2, then O is an open subset of R2 and minus infinity as well. Case 2, if R2 minus, oh, why I am writing R2 here? Oof. If Rn minus O is compact, okay. So I am giving you an intuition. I mean, why is this? I mean, why all of a sudden this comes? I am giving you an intuition. So suppose you have R, okay, and the infinity is here. So case 1 is obvious, right? If it is open in R, then it is open in R union infinity. Now you see, so what should be your open sets containing infinity? So it should be like this, right? It should be of the form, what should I say, minus infinity comma A union B comma minus infinity, right? And you see the complement O complement is compact, right? So that's the intuition. Clear? This was a remark 1, and I would request you for remark 2. I mean, we are doing all this geometry for a particular reason, okay?
আচ্ছা, বলছি যে ইনফিনিটি তো কোনো পয়েন্ট নয়,
Hmm.
তো তুমি এটাকে একটা সেটের মানে কি বলবো, একটা সেটের একটা এলিমেন্ট হিসেবে বলছো কি করে?
First of all, realize infinity is just a symbol, nothing else. I can define things at infinity.
বুঝলাম না।
Wait a minute. So remark 2. Rn as a subspace as Rn union infinity has the usual topology. This is clear. Topology of Rn. So you see, I mean, Rn has a usual topology, right? But Rn union infinity, we gave it a different topology, right? Apparently this might not have any connection, but what I am saying is that if you treat Rn as a subset of Rn union infinity, then the subspace topology induced by this topology, following topology, maybe call it tau, okay, is the usual topology of Rn, that is tau restricted to Rn is usual topology or Euclidean topology. Okay, and this is evident by the case 1. If you restrict open sets, I mean, if you restrict it to the Rn, the open sets are only the open sets of Rn. That's it. Abhishek, what were you telling?
আমি বলছি যে ইনফিনিটি তো কোনো এলিমেন্ট নয়, তো সেটা আমি একটা সেটের মেম্বার হিসেবে কি করে ট্রিট করতে পারি? আর সেটা তার থেকেও বড় কথা, তুমি যে সেকেন্ড ডেফিনেশনটা দিলে না, যে ওই মাইনাস ইনফিনিটি বি ইউনিয়ন এ ইনফিনিটি, ওটা তো নিজেই একটা ওপেন সেট ইন আর, তো আলাদা করে আমার ডিফাইন করার কি আছে? ওটা তো ইউনিয়ন অফ টু ওপেন সেট ইন আর, তো ওটাকে আবার আলাদা করে একটা কন্ডিশন দিয়ে লেখার কি আছে?
Okay, that's a good point. First of all, this is an intuition, okay? First of all, this is an intuition. I should have written it like this, closed, okay? So that's not an open set in R, because infinity or minus infinity is not inside R, okay? So what is infinity? So my answer is, infinity is just a symbol. Infinity is just a symbol. By that we mean, so R has a group structure, right? R has a group structure. Sorry, R has a field structure, right? Right, Abhishek? So I am defining plus on, define plus on R infinity, okay? How? So a plus infinity is infinity. Infinity plus a is infinity. A times infinity is infinity. Now there is a reason. How should I write 0 times infinity? Just a minute. What do I need this? Do I need this group structure? Multiplication? No, I don't need this field structure. The group structure is enough. Don't ask me why haven't I taken the field structure, okay? What's wrong with that? Don't ask me that. I won't be able to answer you right now. R is a topological group. Forget that. We will do these things in the quotient topology class if you join it. Okay? For A belongs to R. Okay? So we are defining this. Understood? So infinity is just a symbol. So under this operation, infinity is a group. So R union infinity is a group. বোঝা গেল?
মানে ওই আর কি।
So infinity is just a symbol. I mean, I can understand what you are saying. I mean, you are saying that how should I capture the infiniteness of infinity, right? I mean, infinity is called infinity for a reason. How should I
না মানে
capture the
আমার
infiniteness?
প্রশ্নটা আরো মানে ব্যাপারটা হচ্ছে যে একটা সেটের এলিমেন্ট কি করে হতে, মানে একটা এলিমেন্ট হিসেবে কি করে আমি লিখতে পারছি, এটাই হচ্ছে আমার প্রশ্নটা।
First of all, infinity is a symbol again. I mean, you can never reach there.
মানে আসলে ব্যাপারটা হচ্ছে সেট থিওরি আমরা যেভাবে ডিফাইন করে আসছি, তো এই ধরনের কোন একটা এলিমেন্ট যে সেটের এলিমেন্ট হতে পারে সেটা দেখানোটা মানে জানোয়ার ফ্র্যাঙ্কলিন অ্যাক্সিওমেটিক সেট থিওরি মানে খুব একটা সুবিধাজনক ব্যাপার না, বরং মনে হয় ডেফিনেশনের বাইরে, মানে কাউন্টার ডেফিনেশনের কথাবার্তাগুলো, এই জন্যই আমার লজিক্যালি ইনকনসিস্টেন্ট লাগছে জিনিসটাকে দেখে।
But I mean this sort of operations you will see everywhere, okay, in geometry and in analysis everywhere. The one point compactification is just, I mean, I can understand. The problem is that since I have written infinity, I could have written it like R union X. Mostly they use this notation, okay, mostly they use this notation, but I use this notation so that you can understand the geometry. Had I used this notation, the problem is that you are not forgetting this infinity as, I mean, n tends to infinity, you are taking those things into account. And you will realize every concept you have gone through, including infinity, is consistent with these definitions. Because you see, these multiplications, okay, these are continuous functions from R union infinity to R union infinity. This is to R union infinity is a continuous map. Okay, forget that. Don't go into.
লিনিয়ারও তো মনে হয় ম্যাপটা, বাইলিনিয়ারও তো মনে হয় ম্যাপটা।
Yeah, maybe. Yeah, yes, it is bilinear. Yeah, it's a group homomorphism, so it has to be bilinear. Okay. So why talking about so many such things? You will see in a moment. There is something called Mobius transformation in complex numbers. Okay. Let me see whether we have gone through it or not. See, the problem with complex number, I mean with complex analysis, is it has only 30 to 35 marks in net. Okay. But the problem is that there is no course which will cover these 30 to 35 marks in maybe 2 to 3 months. You see the other modules, each of them are covering at least 65 to 70 marks. And this module is covering almost half of this. But I mean, you can understand this is the only M.Sc level topic in net. That's the reason we are taking almost twice this time. I'm really trying to give you a clearer picture, because there are not many books in which they write things this way. I can pick up a book and I can go through it, but that will take probably 1 year to complete the whole course. Okay, so R union infinity is a group. What I was talking about? Fourier transformation. Sorry, cross ratios and Fourier transformation. Yeah. See these things. Moment. Okay. So first definition. Excellent. Okay, just let me, before I move on to Fourier's transformations, I will give you 2 to 3 minutes. Just go through it. I mean, try to digest what we have done so far. Is it visible at all? Is this thing visible? This first page. Can you see it after zooming? So
দাদা
বল।
বলছি ওই ওখানে আমার একটা ডাউট আছে, ওই যে ফাই ফাংশনটা তুমি এখানে লিখেছো, ওখানে লিখেছো এক্স ইকুয়ালস টু ইনফিনিটি তো একটা 1,0, ওটা কি ওই জিওমেট্রিক্যালি বললে নাকি ওই ফাংশনের ভ্যালুটা বসিয়ে বললে?
Okay, I assume it geometrically.
আর একটু জুম করে
কোনটার
দাও
কথা
না।
বলছে? কোনটার কথা বলছে?
আর একটু জুম করে দাও না।
আরো জুম করলে পুরোটা দেখতে পাবি?
সেটাও
দৌড় বাবা। Okay, just a minute. Let me do one thing. For a while. I'm sending it into the group. I want you to have a look at it for at least 2 minutes, because this might be a one-page content, but this is a lot. 2 to 3 minutes. Just have a look at it before I go to Mobius transformations. We will do a lot of problems in this topic, okay? But first, at least get the geometric intuition right. So I have sent it in the group. Please look at it for 2-3 minutes.
হ্যালো অভিষেক।
হ্যাঁ
হ্যাঁ বলছি তোমাকে, তুমি ওটা আনসার দিয়েছিলে, তুমি কি ওটা আমাকে একটু বলতে পারবে যে ওই ইনফিনিটিভ ইমেজটা কেন 1,0 হলো? ওটা কি তুমি জিওমেট্রিক্যালি বললে নাকি ফাংশনের ভ্যালুটা বসিয়ে
কি
বললে?
কি ইনফিনিটি?
ওই যে সাই, ওই যে ম্যাপটা দাদা প্রথমে বললে না, ওই ইনফিনিটিতে তোমার 1,0 হবে, কোনটা
হ্যাঁ
বলছি
হ্যাঁ
বুঝতে পারছো?
হ্যাঁ হ্যাঁ।
হ্যাঁ, ওটা তো তুমি বললে ওটা আনসারটা, কিন্তু ওটা তোমার কি রেসপেক্টে বললে, মানে জিওমেট্রিক্যাল সেন্সে বললে নাকি আহ কোনো ফাংশনের ভ্যালুতে বসিয়ে বললে?
আমি ফাংশনের ভ্যালুতে বসিয়ে বলছি, কারণ মানে ওরা আরো আরো বেশি মেথডিক্যাল, তো ওই অ্যাপ্রোচটাই মেনটেন করছি।
আচ্ছা, ওখানে ফাংশনে কোন ফাংশনের ভ্যালুটা বসিয়ে মানে বললে একটু আমাকে বলতে পারবে?
ইয়ে 2 ডাইমেনশনে না 1 ডাইমেনশনে, মানে
আচ্ছা,
আর এ
আগে
না
তুমি
আর
ওয়ান
টুতে?
ডাইমেনশনটাই বলো।
আচ্ছা দাঁড়াও দেখে বলছি।
ওকে
ফাংশন
ওকে।
কি দেওয়া আছে? আচ্ছা আমি যদি ওই -1,0 ওই পয়েন্টটাতে বলে দিই তাহলে তো এনাফ মনে হয়। মানে
হ্যাঁ
মানে
হ্যাঁ
আমার
হ্যাঁ
বক্তব্যটা হচ্ছে যে তারপরে ওটা তো আবার হোমিওমরফিক্যালি গিয়েই তো 1,0 গিয়ে ম্যাপ করছে। তো একটা
হ্যাঁ,
বলে দিলে।
বাইজেক্টিভ যেহেতু।
হ্যাঁ হ্যাঁ, দেখছি ফাংশনটা। ফাংশনটা কিভাবে ডিফাইন? এটা ট্যান ইনভার্সের পরে?
ওই কম্পোজিশন গুলো তো বসিয়েছো, কিন্তু ওটা করে বসানো যাবে কি আমি ভাবছি।
আচ্ছা বলছি, যেটা প্লাস ইনফিনিটি
হুম।
সেটা তো ম্যাপ করছে গিয়ে π/2 তে, ট্যান ইনভার্সে।
হ্যাঁ হ্যাঁ হ্যাঁ, একদম একদম।
এবার π/2টা গিয়ে ম্যাপ করছে হচ্ছে cos পাই sin পাইতে।
হ্যাঁ, সাই ম্যাপিং এর দ্বারা।
cos পাই এর ভ্যালু কত?
-1।
আর sin পাই 0? হ্যাঁ 0। হ্যাঁ তাহলে ডান।
হ্যাঁ হ্যাঁ হ্যাঁ।
হ্যাঁ আর
আ আ
আবার এবার মাইনাস ইনফিনিটিটা -π/2।
হ্যাঁ
তো -π/2 বসালে হচ্ছে cos মাইনাস পাই sin মাইনাস পাই। এবার ওর ভ্যালু মনে হয় -1,0ই হবে।
আচ্ছা আচ্ছা আচ্ছা। আর কম্পোজিশন বুঝতে পেরেছি। ঠিক আছে।
Hello? 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 Any questions? কি অবস্থা? Let's use the same notations. Is from C union infinity to C union infinity is called a Mobius transformation sometimes rational or linear transformation. Don't confuse this linear transformation with with the usual one. It's called a Mobius transformation if Z is equal to AZ plus B by CZ plus D for all Z belongs to C. Okay. So basically by that we mean AZ is equal to AZ plus B by CZ plus D for all Z belongs to C, and S of infinity is মা বলেছিল, তারপরে রুবিকে ফোন করতে গিয়ে এমন বিরক্ত হয়েছিলাম যে কল ব্যাক করতে দিই। ও আচ্ছা ঠিক আছে। না না করিস না ভাই, ভালো লাগছে না, রিসার্চ করি এখানে ফেল। শোন না, কালকে দুপুরবেলা ফ্রি আছিস? দেড়টার মধ্যে দিতে। ঠিক আছে আমি কল করবো, ভুলে গেলে তুই করিস। তো ব্যাপার হচ্ছে যে okay, so this infinity is denoted in this just limiting sense. Okay, so there are some terminologies. One is like dilation, hena tena, se somosto bolte hobe. Okay, so definition, this is a translation, so this is a very important observation. Don't worry, I will send you this note. This is a very compact note. the definition are clear. First of all, observe that S is a bijection. So S is a homeomorphism. From C infinity to C, with this being the inverse, okay? And definition, and as you can see, Sz is Z plus A, this is a translation, Sz is Az, A not equal to, this is dilation. Dilation means multiplication. And this is Az is a, and then e to the power I theta z is a rotation, 1 by z is inversion. And we will move on to the following result, that if S is a Mobius transformation, this then S is a composition of translation, dilation, inversion. Okay. Okay. So let's see this proof also. Okay. So please look at this computation. There is nothing much. Just look at this computation. 2 minutes I give you. Just have a look at this computation.
বলছি মোবিয়াস ট্রান্সফরমেশনে কি গায়ে লাগে?
কাজে লাগে?
হ্যাঁ,
চাপের প্রশ্ন, একটু বাইরে দেখতে পারিস। আজকের ক্লাসে মনে হয় না, probably not in this class, but we will define orientation and things like that. না না yes সেটাই বলছিলাম আমি আজকে সকালে কি মনে করবো নাকি লাভ নেই ঠিক আছে তাহলে কালকে সকালে so there are some things like this is a bit mechanical but from this onwards you will get a lot of this cross ratio. So what about fixed points? What about fixed points? Fixed points of a Mobius transformation. So if S of z, that is Az plus b by Cz plus d equals to z, then you get a quadratic by solving this. What is that? What is that? It is Az plus b plus Cz square and equals to Cz square plus dz. Az plus b by Cz square plus dz. Cz square plus z into b minus a plus b, right? Right. So the quadratic can have only two distinct values, right? So if S has more than two fixed points, then Z equals to Z. Okay, you understand? That is clear, na? Because this whole quadratic thing, we are assuming that C is not equal to 0, right? Otherwise it's not a quadratic. So if C is 0, you get rid of this, then it becomes Az by b plus Cz by d. Equating stuffs, you understand that it is just the identity function and nothing else. Okay. If it has more than two fixed points, then you I hope it's clear. Then the equation is identically 0. Okay. That is Cz square plus z minus dA.
মনে হয় দুটো মোবিয়াস ট্রান্সফরমেশনের 3টে পয়েন্ট ইকুয়াল হয়ে গেলে তো দুটো মোবিয়াস ট্রান্সফরমেশন একটাই মানে একই এক্সপ্রেশনের হয়ে যায়।
Yeah, we are going on to that. That's the next remark. So that implies C equals to 0, D equals to A, and B equals to A. So SZ is Z. So let's move on to the next remark. Okay. So corollary is ST from C union infinity be two Mobius maps, be two Mobius transformations with SZI equals to TZI for I equals to 1, 2, 3 and ZI not equals to ZC. Then S T inverse ZI is ZI for I equals to 1, 2, 3. So you see composition of two Mobius transformation is a Mobius transformation again. You will be able to show this sort of things. Okay. I mean, you take two Mobius transformation, you compose it by do S compose T of Z and all that. These are basics. I mean, if SZ is AZ plus B by CZ plus D and TZ is say what? EZ plus F by FZ plus G. You do S compose T of Z. Okay. You will come up with another Mobius transformation. The inverse is also a Mobius transformation and so on. So S compose T inverse is a Mobius আমি DRB গুলিয়ে ফেলছি কি বলবো is a Mobius map with three distinct fixed points, which implies S compose T inverse is I. Okay.
তোমার কি ডিসলেক্সিয়া আছে?
আমার মনে হয় স্লাইটলি মানে টু সাম এক্সটেন্ট খুব স্লাইট আমার এমনি তো I mean I have a difficulties in remembering stuff. I mean I can forget a definition reading I mean about 100 times.
ও তাহলে সিরিয়াস ব্যাপার, আমি মজা করে বলছি না।
Nah, I just keep forgetting stuffs. I can only remember things which come natural to me. I mean, if all of a sudden you, I mean, suppose you all of a sudden you, I mean, ask me the definition of a cross ratio, I will have to check things out. Okay. I'm not good at remembering stuffs. I try to, I mean, find out, I mean, do as much as possible by myself. But I mean, this is strictly in mathematics. I mean, I can remember numbers or numerics very well. I can remember dates very well. I can remember details. But when it comes to
না,
mathematics,
ডেট আর নাম মনে রাখতে তো প্রবলেম হওয়া উচিত তাহলে।
no. But I mean,
আমার কিন্তু
yeah,
হয় প্রবলেম।
date remembering date is not a very challenging thing to me. But remembering names are.
হ্যাঁ, নামে হয়, খানিকটা ডেটেও হয় আমার, বেশ খানিকটা।
Okay, so we will end this class by defining what a cross ratio is. So you think, so you see again, I mean, this is the definition of a cross ratio. Okay, so first define a cross ratio. So definition of a cross ratio, and you will rightly see what I was talking about. Okay. So first, find a Mobius map that sends, so fix Z2, Z3, Z4, okay, that sends, I think Z2 to 1, again you see the problems, Z2 to 1, Z3 to 0 I think, and Z4 to infinity. Now you ask me what is the Mobius transformation. I have read it 1,000 times, but I won't be able to remember it. Instead, I would like to just do it myself. Say, I mean, you have to send Z3 to 0, right? So my first peak will be Z minus Z3. Just do it in the numerator, in the denominator. Then you see, we have to send Z2 to Z3. I mean Z2 to 1, right? So how about doing this? You put Z2 here instead of Z2, instead of Z, you get 1. And you have to put Z4 to infinity. So thus you divide by Z minus Z4. Okay. Now you have to balance things out. I mean, you have to, sort of make this. So you see, Z3 is going to 0, Z4 is going to infinity. I'm trying to write this as Z. So you see, as Z2, as Z3 is 0, as Z4 is infinity, but as Z2 may not be 1. So just do this. Okay. So doing this thing by myself is easier for me than remembering this expression. That's the reason I find this MCQ exam so tricky. I can clear probably a few more times the ISI written, the TIFR one, but NET and JAM, these things are very tricky to me because these are not very conceptual exams.
ওটা তো ইয়ে
more
সেন্ট্রাল
than
গভর্নমেন্টের এক্সাম গুলোই তো এরকম ফালতু হয়।
more than concept you need speed and accuracy. More than concept you need speed and accuracy. I'm not saying that these are not at all conceptual, but what I'm saying is that the center of gravity, it's towards speed and accuracy, is more towards speed and accuracy than towards concept. Okay, so I think this is correct. Yeah, this is correct.
কিন্তু মানে আমি এটা বুঝতে পারলাম না যে এই যে এই ম্যাপটা তুমি লিখলে, মানে মানে তুমি বলছো যে এটা Z2 কে 1 এ পাঠাবে, Z3 কে 0 তে পাঠাবে, আর Z3 কে ইনফিনিটি তে পাঠাবে।
Z4 to infinity।
হ্যাঁ, Z4 কে ইনফিনিটি তে পাঠাবে। তো মানে আমি এটা বুঝতে পারছি না, তুমি ম্যাপটাকে তৈরি করলে কি করে? তুমি ম্যাপটাকে তৈরি করলে কি করে ক্যালকুলেশন করে?
Let's do all over again. So you see, you have to send Z3 to 0, right? So first, at the numerator, you have to have this expression, Z minus Z3, right? So in the numerator, you have to have this expression, right? Correct? And in the denominator, you have to have this expression. What? Correct or not?
হ্যাঁ দাদা।
If you don't have Z minus Z4 at the denominator, how will you send Z4 to infinity? And if you don't have Z minus Z3 above, how will you send Z3 to 0?
আচ্ছা আচ্ছা আচ্ছা।
Now you put Z2 there and multiply by the reciprocals. That's what I am doing.
আর এবার Z2 টাকে 1 কি করে পাঠাচ্ছে?
Now you see, it's automatic. I have put Z2
আচ্ছা,
with
বুঝেছি
the
বুঝেছি।
previous expression, then just multiplied with the reciprocal. That's it. So, there are a few special cases, I think, which is like this. Let's copy it. Okay. Okay, so I mean, let's conclude today. We will move on to, let's try. We will move on to proposition. I mean, things regarding cross ratio. Let's see how much we can go.
বলছি ওই জায়গাটা আরেকবার বলবে
Let's see, orientation principle. I don't think it will be completed in the next class. Probably will. Yeah. Go ahead. What?
বলছি তোমার ফোর জেড ফোরটাকে ইনফিনিটি পাঠালাম ঠিক আছে, জেড থ্রিটাকেও জিরোতে পাঠালাম ওটা বুঝতে পেরেছি, কিন্তু জেড টুটাকে ওয়ানে পাঠাবো ওটা ইনটিউশনটা কি আরেকবার বলবে?
No intuition. Put Z2 in this expression. What do you get? Right?
হ্যাঁ ঠিক
So
আছে,
you have to multiply by the reciprocal to get 1.
আচ্ছা হ্যাঁ হ্যাঁ
What I
বুঝতে
have
পেরেছি
done.
এবার। হ্যাঁ হ্যাঁ ক্লিয়ার, ঠিক আছে।
Okay. So that's it.